I'm presenting my project on neural control, which was essentially controlling a simple dynamic system using two neural networks. The results of this project were unsatisfactory. One neural network was able to simulate the dynamics of the system, but the controller network was not able to produce a control signal that matched the classical linear quadratic regulator control policy. Um, so the system, to give you some more details, is described here. This is the inverted pendulum on a cart. It is a simple control input of a force pushing laterally on the cart, and the goal is to stabilize this pendulum arm in the upwards position where it's naturally unstable. You can see here the Lagrangian formulation of the dynamics leads to these differential equations. And this is a linearized model that was successfully used to control the dynamics. So you can see here an example of the dynamics being controlled with a simple linear quadratic regulator approach. However, this model was just created as a comparison model for the neural approaches that were going to be designed in this project. The neural approaches were developed here using PyTorch as a framework. The emulator model that basically took in a state value and output uh, the resulting state after zero point 0.1 seconds of time evolution, essentially reproducing the flow map of the system, was represented by this model, which was just a feed-forward network progressing from 32 hidden layers to 64 and back down to 4. And then the controller network was a recurrent neural network that first took an input state, passed it through this sequential network, output a single value for the control signal for this state. Then it passed this control output into the emulator network that it has here as a variable, um, and then it added the output of the emulator network to itself and passed that in as a new input. So it was recurrent over k layers. Um, Unfortunately, that did not that was not able to control the system. The details are discussed in my paper and what did converge and what was not able to converge and not able to provide a adequate control signal. However, I will show here the system simulating the unforced dynamics. As you can see here, the pendulum just drops immediately, and I will also show the best, at least by the convergence metrics control model, that nonetheless was not able to have any meaningful impact on the real system. You can see here it's doing something, but it's not able to achieve any sort of actual control or stabilization. The reasons I hypothesize are included in my paper. Thank you for watching and happy holidays.